record this presentation. And so, hi to everybody. Welcome to another presentation from the data science group by HVL. Today we have Philippe Fournier-Viger, and do you want to introduce a little bit?
Yeah, I can introduce.
Jerry, yeah, he can you can introduce him. Yeah.
Okay.
Thank you.
Yeah. So hi everybody, welcome to the AI and the data science series in HVL. So I'm Jerry, and this presentation also this event is joined with the IEEE Young Professional in Norway section. So today we are glad to have Philippe Fournier-Viger to be the presenter of this seminar. So Philippe is one of my very good friends in China, and he is working in China right now. And before he was my colleague, we were working in Harbin Institute of Technology, Shenzhen campus. So Philippe came to China and became a full professor at Harbin Institute of Technology, and he also got a title which is called the National Talent Title from the National Science Foundation of China, which is a very good title in China. And he published more than 300 research papers regarding the data mining, intelligence system, and the industrial application. And he also received more than 7,000 citations from the Google Scholar citations. And he is right now associate editor-in-chief of Applied Intelligence Journal, which is ranked 2 in Norwegian system. And he's also the editor-in-chief of data science and pattern recognition. It's a journal that we work together for the data science and the AI applications, something like that. And he is the founder of the SPNF data mining library. So SPNF is a very famous library in data mining, and it has more than 119 algorithms right now, and they receive more than 950 citations for these libraries. And we publish and release more than, together maybe more than 100 algorithms, right? I guess. Yeah. And he recently added several books from Springers, and such as the high utility pattern mining theory of algorithms and applications. And we work together for the UDML series workshop at ICDM and the KDD conferences. ICDM and the KDD, they are the top conferences in data mining. And his research interests include the data mining, algorithm design, pattern mining, sequence mining, big data, and industrial applications. Okay, so let's Philippe, and yeah, stage is yours, Philippe.
Oh, thank you so much for the invitation and also for the nice introduction. Okay, so I will share my screen. Okay, so is it everything okay?
Yes.
Yes, okay, great. I will put full screen. Okay, so again, thank you very much for the invitation. It's a pleasure to have this talk today. Today, I want to talk to you for my talk about discovering interesting and interpretable patterns in the data. Data may be from industry, but it can also be other types of data. So the idea, we want to find patterns in the data that are interesting. They tell us something interesting, but also interpretable, not like a black box. We can also understand, maybe, to take some decision and or learn something about our data. Okay. So there was already some introduction, very nice introduction, just to show you where I am. I'm from Shenzhen in China, and the Harbin Institute of Technology is in the south of China, just beside Hong Kong. Okay. So let's start the talk. Nowadays, there is a trend about building some intelligent system in many fields. Maybe intelligent system for the education, for the healthcare, to manage the telecommunication network, for industrial systems, and so on. And to build all these intelligent systems, we need to have some data to train the system or to build the models and so on. And also, not only this, but all these systems will also produce some data. It could be some usage log of the system, some alarm log, fault log, or the sensor data, or data received from other systems, and so on. So nowadays, we have a huge amount of data, like the big data and so on. But having a lot of data is nice, but one major problem is if you have a lot of data, you want to be able to analyze the data, to learn something from the data. Because if you just have data but you don't know what to do, then the data is useless, maybe. Okay. So there is a need to not only have data or do something with the data, but also to understand the data. So nowadays, there's a lot of work on machine learning and so on. Some machine learning models can take the very good decision. But one problem is that sometimes the machine learning models, they are more like a black box. So maybe they give you the very good accuracy for something, but maybe you don't know why, or because it is like a black box, okay? So in this talk, I will talk to you about some other approach. Instead of having a black box, we want to find patterns in the data that will be more like a glass box, where help us to understand really what are the correlations in the data, some patterns. Okay, so I will talk to you about what we call the pattern mining. Pattern mining means to look for the patterns in the data that will tell us something. So we want to find patterns in the data that will give us some valuable knowledge, tell us something we don't know before, can help us to take some actions, like such as to repair a system and so on. And also interpretable by humans, as I said. In the work on pattern mining, the researchers have developed different algorithms to find all different kinds of patterns. So for example, here I give you a few examples. We have what we call the item sets. Item set means some values in your data that appear, for example, many times together. Okay. So for example, if you look at shopping data, it could be many people buy apple with bread together and so on. So if you find the item set like this, maybe it gives you some insights about what the customers like to buy. You can take some marketing decisions and so on. Other kinds of pattern maybe is the subgraph. In a graph, maybe you want to find some graph or some structures in the graph that appear many times. Also, at the bottom of the PPT, I have another example, is about the computer network. So if you have a big computer network, in the network, maybe there are some alarms or some faults, some errors. And we can find the patterns, like if there's a fault in computer A, then there's 60% chance that the computer B will shut down or have another problem. And to find these patterns, is useful to understand what happened in the computer network, but also for the maintenance. If you know the error A will make some error B in the network, you know you should fix the error A to solve the other problems in the network, okay? So this was some example. Actually, we had some industrial project with the big company in China, where we look at the computer network like this, okay? Okay, so as I said, we want to find patterns in the data to understand the data. So in what kind of data? So of course, there are different types. It could be the relational database, the graph, the text, or the special data like the cars, about driving, and so on, okay? So in this talk, I will try to give you some overview about what we can do in this field. So I will talk to you about shopping, okay? So like what the people buy in a store, we call the transaction database, okay? The database, what the people buy. So in particular, I will talk about market basket analysis. It means to analyze what the people like to buy together, okay? So why we want to do this? Because we want to understand the behavior of customers, maybe for marketing or to improve the management of customers and so on. So I will take some simple example to give you some idea about what we can do to find patterns in the data. So here I have an example. I have a database about what the people buy, a transaction database. So we have some items in this store we call A, B, C, D, E, okay. A is for apple, B is for the bread, C is for the cake, D is for the dates, and E is for eggs, okay. So let's say we have a small store, and then at the bottom of the slide, you can see a database, okay. We have 4 lines. Each line is a transactions, what the people buy. So in the transaction 1, T1, we know the people buy A, B, C, D, E, apple, bread, cake, date, and eggs. In transaction 2, people buy A, B, E, apple, bread, and eggs, and so on, okay. So this was some example of data, okay. Now, what can we do with this data? If we want to find patterns about what the people like to buy together, there can be millions of patterns. For example, you could buy apple with bread, apple with egg, apple with cake and bread, bread with cake and eggs. So there are so many possibilities, okay? So in the real life, there can be millions of patterns in the data. So we need to define what kind of patterns we want to find in the data. So we need to use some measure, some interestingness measure, okay, like the support. Support means the frequency, okay. Maybe we want to find what the people buy many times together. A lot of people buy apple and eggs. Or there are some other measure like the utility, the money. We want to find what makes the most money in the database and so on. Okay, so whatever patterns we want to find, we need to define first what we are looking for. We want to find what the people buy many times or what makes the most money and so on. So the goal is we want to have some algorithms to exactly find the patterns we want in the data. And we can apply this to the real data also. So for this research area, for these problems, there's always only one solution. We want to find some patterns, and we want some algorithm to give us the solution, but there are only one solution. So let me show you some examples. I will show you first the basic task we can do in pattern mining. We call this to find the frequent patterns, like find what the people buy many times together. Okay, we call this the frequent patterns. So the input of this problem is a database of transactions. And then we need to choose a parameter we call the minimum support, or min-sub. It means a minimum number of times. Like we want to find everything the people buy at least 5 times or 2 times. Okay, so this is the parameter. And the output, the result, will be the frequent item set, the sets of products the people buy many times together. So let me show you this with some example. It's really easy to understand. Okay. So on the left, we have a transaction database, like the one I showed you just before. Then we set the parameter, the minimum support, to 2. That means we want to find the sets of products appear at least twice together in the database. Okay. So on the right, you can see the result. We find the item set A. A is for Apple. Appear 4 times. The support is a 4. Okay. A is a 4 because it appears in transaction T1, T2, T3, and T4. We have the A. Now, another item set is A with B. Appear 3 times because we have AB in T1, AB in T2, and AB together, apple and bread, in T4. Okay. So this is a very classic model in data mining. Find the values appear many times together in the database. It can be used to analyze the shopping data, but also all kinds of data. It could be the words appear together in the text, or the computer problems in a computer network, and so on. Okay. But here I use the example about shopping to explain. So if we want to solve this problem, I want to show you the basic idea how to solve the problem. Okay. So there is one naive approach. It is to read the database to count how many times each item set appears in the database. Okay. So for example, if you look on my PowerPoint, we have A. Okay. We have AB, apple and bread, apple and cake, apple and dates, AE, ABC, ABD, and so on. So here I have only 5 items in my database, A, B, C, D, E, but there are 31 possibilities. Okay, I do not put all of them. But you can imagine if you have a store like Amazon, there are millions of items. Okay, there will be so many possibilities. So actually, if we have n items, there will be 2 to the power of n minus 1 possibilities. So if you have only 500 items, then you can see how many possibilities at the bottom of the slide. Okay, so many. So because of this, we cannot just look at all the possibilities. We need to use some good algorithm to find the solution for this. So the basic idea we use in pattern mining is called the a priori property, okay, used by the a priori algorithm. So the idea is, if you have some sets of item X and another set y that is a superset of x, you know that the support, the frequency of y must be less than or equal to the frequency, the support of x, okay? So let me explain this with an example to make it easy, okay? So if we look at the database at the bottom, and we have the sets of item A. Let me see, okay. So, sorry, we have the sets of item AB, okay. AB appear 3 times in the database. So, what the properties say, if you have a superset of AB, like ABC, ABC cannot appear more than 3 times. Because, of course, if apple and bread appear 3 times, apple, bread, and cake together cannot appear more than apple and bread, okay? Because you add something else. So if you have AB, a superset of AB, like ABC or ABCDE, must appear 3 times or less, okay? So using this property, we can design the good algorithm to find the solution. For example, if we want to find what the people buy 5 times, and we know AB appear only 3 times, then we know everything with AB is not frequent. We can eliminate to save the time, okay? So, to solve this problem, there have been many algorithms about this. But these algorithms have some important limitations. The first one is that many frequent patterns are uninteresting. So, for example, if you buy bread and milk together, we find this in the data. People buy bread and milk, okay? But this is something obvious, maybe, okay? We know already everyone buy maybe the bread and milk. And not only this, but bread and milk don't make a lot of money, okay? It is something probably very cheap. Also, another problem is we don't have the quantities. That means if you buy 1 bread, or you buy 5 bread, or 10 breads, in this problem, it is the same thing, okay? And also, the items don't have the weight. If you sell 1 bread, or you sell 1 diamond, okay, in this problem, it is the same thing. But of course, in real life, if you sell the gold or the diamond, the gold or diamond will make more money, okay, than the bread. So, there are some limitations. So I will talk to you about another problem we call the high utility item set mining. This is some extension of the frequent item set mining. The goal is to solve these problems, okay? So this is a popular topic, and that's why I talk about this. Then I will show you some of my work also on this topic. So in high utility item set mining, we have a database, as you can see on the left, okay? It is a little bit like what I showed to you before. But here we have some numbers. If you look at the first line, okay, T1, we have A1. A1 means 1 apple, okay. B5 means 5 bread. C1 means 1 cake, okay, and so on. So now here we have the quantities. You can buy 1 bread, 5 breads, and so on. And also, if you look at the table on the right, we have another table that tells us about the profit, the money, okay. So here, A5 means if you sell 1 apple, it makes $5 profit. B2 means 2 $2 profit, and so on. Okay. C1 means $1 profit for the cake, and so on. And now we need to set a parameter, the minimum utility, the minimum amount of money. Okay. And our goal is to find what make at least this amount of money. So here I show you some example what we want to find. Okay. So we set the parameter, the minimum utility, to $33, and we find 4 item sets you can see at the bottom of the slide. So BDE is $36 profit, is more than 33. So it is a high utility item set. It is in the result. BCD is $34. BCD $40, and so on. Okay. So this is what we want to find. But one thing important I did not explain is how we calculate the money. Okay. So for example, let's have a look at the item set BDE, okay, like bread, dates, and egg, to see how to calculate the money. Okay, so let's look at the first line of the table on the left. We have B5, okay, so that means 5 bread, but the bread is $2 each, as you can see on the right. Okay, so 5 multiplied by 2 will be the money for the bread in transaction 1. Okay, now in transaction 1 we also have D 3 times, and the profit of D is $2. So 3 multiplied by 2. Okay, as you can see here on the PPT. So, and we continue the calculation like that to get the total money of BDE. Okay. So, one thing is important to say. We want to find BDE together. Okay. In some transaction, we have only B or only E maybe. But we want to find the money for BDE that are together. So why this problem is interesting? One reason is that it is difficult. Okay, so I want to show you why in this slide. I think it's interesting. So one thing that is special about this problem is that the utility, the money, is not monotonic or anti-monotonic. So what does it mean? Okay. If you look at the bottom of the slide, you see the money for BDE is $36. And the money of BCDE is $40. And ABCDEF is $30. So what I want to show you here is that if you have a set of items like BDE, the superset of BDE can have more or less money, okay, than BDE. So BDE $36, but the superset BCDE will make more money. But the superset ABCDEF will make less money, okay. So this is different than the frequent item set mining I showed you before. In the frequent item set mining, if you have BDE 3 times, you know that the superset of BDE cannot appear more than 3 times. But here, this is not true for the money, okay. So I guess you want to know why, okay. So the reason is, if you buy more things together, you will think it will make more money because you buy more things together, of course. But if you buy more things together, it will appear less often, okay, not so often. So if you buy more money because you buy more things, but less money because less people will buy all these things together, okay. So if we want to solve this problem, there are many algorithms. So here, there's a few of them, like EFIM is we propose with Professor Lin, okay. Yes, here today also. So the key idea in this problem, how to solve, is we use some upper bound on the utility that will be anti-monotonic, that will always decrease for the supersets. And then we don't need to look at all the possibilities. So today, I will not show the details about these algorithms because we don't have so much time. And I just want to give you some overview about what kind of patterns we find in the data we can find. And also to talk to you about some recent trends and challenges related to this, okay? So all of this is useful, but there are some problems about this. Especially, we don't care about the time, but the time is really important in real life. If you do the data mining, normally you should not expect your model to always be true over the time, because over time, the things might change, for example. So for shopping, it is the same thing. The behavior of the customer maybe will change over time. And some items may be more or less popular and so on. So I want to give you some overview about what we can do if we add the time to this. So in one paper I did with Professor Lin, okay, Jerry, we looked at the recent high utility item set. So the goal is we want to find what the people buy together and make a lot of money, but also the recent means recently made a lot of money, not in the past, okay? So we use some decay function to give more weight to the recent times compared to the past. So here I have a picture at the bottom. I show you the money over the time, okay, in my picture. Let's say this is the money over time for the Apple, maybe. So maybe you will find that over time, the money for the profit for the Apple will increase. And recently, it will make a lot of money. So we designed some algorithms for this, okay. Another work we did related to the time is about finding the concept drift in the data stream. So here we look at the shopping data, and we want to find a point in time where there will be a drift. Drift, what does it mean? Okay, a drift means a big change in the data. So here we have, for example, if you look at the picture at the bottom, I draw a line to show that at some place there is a big change in the data. For example, maybe on the national television, they say this product is very good, and then everyone starts to buy it, for example, okay. So we want to use some algorithm to find this drift. So to do this, we use some statistical test, actually. Okay, so this is just some overview. Another paper we did, also I did with Professor Lin, okay, in China, was about finding the peak high utility item sets. So we look at the money for some shopping that the people buy, for the products that people buy, and we want to find in time some peaks. Okay, peaks mean that the money will increase and then decrease later. So during a short period of time, the money will go up a lot more than usual. Okay, so for example, during the Mid-Autumn Festival in China, people will buy a lot of cakes, okay, but mostly only during this week or a few weeks maybe, okay. So, or maybe in Norway, before Christmas, you will buy some special gift and so on, okay. So this will be like a peak over time. Other thing we did in other papers, and also with Professor Lin, we try to find the trends in the data. So for example, the sales will increase over time or decrease. So a trend means it increase or decrease over the time. So if you look at my picture, you can see some increasing trend at some point in time, during some time interval, okay. So we designed some algorithms to find this automatically in the shopping data. Another interesting problem about the time I did with Professor Lin also is about the periodic high utility item set. So what does it mean, periodic? Periodic means something always repeat over time, very regularly, okay? So for example, if we look at the shopping data, maybe we find that the people buy the cheese with the cake, the wine and the cheese every week, okay? And if this is periodic, then it will appear almost every week. The people buy cheese and wine together. So if you find this kind of patterns, it can help you to understand the data. You can learn about the habits of the customers. It really tells you something, okay? And also, we can use this maybe for recommendation and so on, okay? So if you buy wine and cheese every week, we can send you the SMS on your phone to give you a discount to buy the cheese and wine and so on every weekend, maybe to remind you, okay? So I will skip the details about this, okay? I have more details in the PPT. I will skip about this. There are also some other problems we can study, okay? Here I want to give you just some overview. Another problem related to this is the cross-level high utility item sets. So the idea is, again, we want to look at what the people buy, okay, to find what makes a lot of money, the utility. But also, as you can see on the right, we have a taxonomy. So it looks like a tree. The taxonomy will tell you, like cheese and yogurt and milk, they are the dairy products, okay? So we have one category is the dairy products. Then inside we have the milk, the cheese, and the yogurt. And in the milk, we have different types of milk and so on, okay? So we have a taxonomy of all the products. And then we can find the patterns, like I show you at the bottom, that will tell you, for example, if you buy any kind of milk, you will buy any kind of chocolates, maybe, okay? Or if you buy any kinds of computer, you will also buy a keyboard and a mouse. But we don't need to know which mouse because we use the taxonomy, okay? So anyway, that's just the idea about this work. I did also with Professor Lin. Okay, so if you are interested, you could find more details also in the paper and so on. I also did a lot of works. So before I show you some other things, for example, I look at the real shopping data in the US about the alcohol, okay, like the beer, the wines, and so on. And we find some patterns, like if you buy the cordial and liquors, then you will buy the neutral grain spirit together, maybe. These are some categories of alcohol, and it makes a lot of money together, okay. So we found this in the public data. We did not analyze the details, but it's the kind of things we could find, okay. There are many other things in my PowerPoint, okay. I will just show you some idea quickly. We also did some works about the graph, okay. So in a paper in 2019, we designed an algorithm called TKG. So the goal is, we have a database of graph, as you can see on the left, okay? So in the database on the left, we have 3 graphs, graph 1, 2, and 3. And then we set a parameter we call K. That means we want to find the top 3 patterns that appear the most often in the graph. So the result will be what you see on the right, okay? So these 3 subgraphs appear the most often in the database. So this can be used, for example, to analyze the chemical molecules and so on, okay? So what I want to say here is that there's a lot of different kinds of data, like the shopping data, like the graph, like the sequences or the time series. And in all these kind of data, you can have some algorithms to find some patterns that will help you to understand the data and maybe reveal something interesting that you can understand and maybe also use to take some decisions. So let me continue about this. Okay, so I want to talk to you about some challenges in this field, to give you some overview, okay? So if you want to work in this field, some challenges is to design the more efficient algorithms, because there are a lot of possible patterns. So we need to design the good algorithm using the special data structures, the special tricks for programming and so on. And we need to design some good models and so on. Also, we can use the new platform, like the multi-threading, the GPU or big data and so on. And some current challenges is to handle the more complex data, to find the more complicated patterns, and also to design other measures to find the patterns, not just the money or the frequency, but maybe some other things like the periodic patterns and so on. And also, there are a lot of possible applications for this. Some trends currently I see in the research about this. There are some researchers, they try to find the statistically significant patterns. So they will combine this idea of finding patterns with some statistical tests to make sure the patterns are not just noise or something like this. So this is one trend. There are some good papers about this in recent years. Also, the data streams And also, there are a few papers about the parameter-free algorithms. So you don't need to choose any parameters, and you can find the good patterns in your data. And there are some other things. Okay, this is just a few trends I see when I look at the papers. Also, nowadays the machine learning is very popular. Okay, so one opportunity, I think, is to try to bridge the gap between the pattern mining and the machine learning. So machine learning, often there are many models, is more like a black box. Pattern mining is more like a glass box. You find some patterns that are maybe more easy to understand sometimes. So there are many ways how to combine, but I think still some research need to be done. Okay. So one way is to use the pattern mining to do the data exploration. So before you do your model, your machine learning model, you can look at the frequent patterns or to see what kind of correlations in your data. Okay. And maybe it can help give some idea. Another possibility is to use the patterns to create some embeddings for the graph or sequence or transactions. So there are a few papers I saw. First, they find the patterns in the data, like the sequence, and then they use this to do the graph embedding or sequence embedding and so on. So, but I don't work much on the machine learning. I'm more a data mining guy, so I don't know so much about this, but I think there are many possibilities for this. Here I show you an example also of real application. So we use, I'll just say very briefly because we don't have much time, okay? But I had a real project with a company in China where we look at the network data, the problems in the network. And we look at the alarm data and we try to find the correlation between the alarms to try to save money to the company, okay? Because if you find there are some problems in one computer and then another, then it can help you to fix the problems in the computer network, reduce the maintenance costs. So this is like a graph with some attributes and so on. Okay, so let's continue briefly. So I want to tell you quickly, we have a software. I'm the founder, and I do this software with Professor Lin, okay, SPMF. We offer a lot of algorithms to find patterns in the data. If you are interested, you can look at this. It is open source, and there are the free database also to test. So I'll skip the details about this. We also have a few books, some me and Professor Lin and others about pattern mining. And as said before, we have one workshop called UDML about pattern mining at the ICDM this year. Okay. And also, I'm part of another workshop about machine learning for software engineering. If you have some papers, you're also welcome for both of these workshops. Okay. So that's all for my talk. I hope to give you an overview about what we can do about pattern mining, some challenges. Thank you.
Hey. Thank you, Philippe. Yeah. Any questions? Oh, okay,
Yeah.
I got it. Yes.
Yeah, no, thank you, Philippe, for the very nice presentation. It was really clear, and actually, yeah, that's I'm working a lot with machine learning, and I know that the terms of the aspect of explainability and interpretability of machine learning is actually very it's very important also, because as you said, usually these models, especially machine learning models, are especially deep learning models, are very black box, so you don't really know what's going on. But is pattern? I just wanted to ask if these methods that you presented, are they they can also forecast, right? They can find the pattern, but then how they I mean, are they really explainable? Can you really understand? Because you find, for example, you find in an algorithm is you can design an algorithm to find that there was, for example, a peak, or there was a strange behavior over time. Can you see? Can you understand why from the pattern? Or because I think it's also like a machine learning model can actually probably estimate the strange behavior. For example, I was thinking about some, for example, anomaly detection algorithms. So I think it's probably related to the gap that you mentioned between like merging together the machine learning and the pattern mining approaches. I think it's.
Yeah, I think very interesting observation and question. Thank you. It's nice. So yeah, so if you find the patterns, the patterns tell you something, but to really understand why the people buy something, then you need to do some effort to understand why there's a peak, because it's Christmas maybe, or
Yeah, exactly.
but the data will not tell you it's Christmas, something like that. Yeah, and one thing I think for the pattern mining, you can use to do some prediction. You find patterns, and then you can recommend to buy something together and so on. But normally, in general, the machine learning model will do the better prediction than the pattern mining. So for me, I think the main advantage for the pattern mining is about the explainability.
Okay.
Like for maybe the decision maker, they want really to understand, not just, but sometimes also machine learning is what we want. We want to increase the money. Okay, we don't need to know why it works, something like that. Yeah.
Yeah.
Yeah. So I think that there's something for everyone.
Yeah, any questions? Yeah, okay. So I got a question for you, Philip.
Yes.
Yes, as I know, you published a paper regarding the pandemic issue. So I'm wondering, how do we use a pattern mining approach to solve the problems in this kind of pandemic period? Do you have any idea?
Okay, thank you. That's very interesting. Okay. So we did one paper actually about I'm part of one paper like where we analyzed the DNA of the coronavirus actually. We look at the data collected from different locations about for the genome sequence, the DNA, like in Europe or in US and so on. And we try to find the patterns in this, like, but it was more exploratory, actually. I could not say we find something that will be groundbreaking, or that will make a new medicine or something like that. But I think other things, like we could do the pattern mining, look like how the virus will spread. If we do maybe the spatial pattern mining, that will be maybe more interesting. I think there's something to do.
Yeah, that's fine. Yeah,
that's just an idea.
Yeah, but because I think pattern mining, for example, like a screenshot pattern mining, probably it's very useful to find the relationship of the items or the data, right?
Yeah.
So probably also I think kind of the shared data trade pattern mining. We can find kind of the trade in some specific periodics, right? So maybe it's quite useful to solve the problem in this kind of a pandemic situation. Anyway,
Maybe we could do something together.
yeah, exactly. Yeah, Philippe is very good friend of mine, and we work so many papers together. Yes. Any other questions? Okay. Yeah. So I think that's for all right now. And thanks, Philippe, for a very great talk and also give us a very brief introduction of the pattern mining. And I do believe this kind of a pattern mining, even for the SPNF project, you can just try to access it and download the software. Probably it's very useful to solve the problem that you are working right now. Yeah, and also the pattern mining is kind of a very interesting issue, and it can be applied in many specific domain and applications. Try to figure out the specific and the interesting patterns in your domains. So I think that's even right now we have a lot of AI and machine learning models, but I do believe the pattern mining is also very useful right now. Yeah, to conquer some issues. Yeah. Anyway, thank you, Philippe, for a very great talk. Yeah.
Thank you so much. Very happy to be there today.
Yeah. Have a good day. Yeah.
Yeah, you too. See you.
Okay, see you. Yeah, see you
Thanks
guys.
for the talk.
Yeah.
Thank you.
Hey, see you. Bye-bye.
Bye.
Thanks for the talk.
Okay. Yeah.